Hello and welcome to the stream. I am Jared. You can call me Jardo, and we are working on Advent of Code puzzles today. We completed day 10 last session in reverse order by coming up with a solution that did not work for part 1 but happened to be the solution for part 2, and then altering it to solve part 1. This was I had the foresight in that, so I did actually commit the thing that I thought would probably be part 2 when I realized the mistake I'd made. So that was kind of funny. Plutonian pebbles. The ancient civilization on Pluto was known for its ability to manipulate space-time, and while the historians explore their infinite corridors, you've noticed a strange set of physics-defying stones. At first glance, they seem like normal stones. They're arranged in a perfectly straight line, and each stone has a number engraved on it. The strange part is that every time you blink, the stones change. Sometimes the number engraved on a stone changes. Other times a stone might split in two, causing all the other stones to shift over a bit to make room in their perfectly straight line. As you observe them for a bit, you find that the stones have a consistent behavior. Every time you blink, the stones each simultaneously change according to the first applicable rule in the list. If the stone is engraved with the number 0, it is replaced by a stone engraved with the number 1. The stone is engraved with a number that has an even number of digits, it is replaced by 2 stones. The left half of the digits are engraved on the new left stone, and the right half of the digits are engraved on the new right stone. The new numbers don't keep extra leading zeros. 1000 would become stones 10 and 0. Okay, yeah, that makes sense. If none of the other rules apply, the stone is replaced by a new stone. The old stone's number multiplied by 2024 is engraved on the new stone. No matter how the stones change, their order is preserved, and they stay on their perfectly straight line. How will the stones evolve if you keep blinking at them? You take note of the number engraved on each stone in your line, your puzzle input. If you have an arrangement of 5 stones engraved with the numbers 0, 1, 10, 99, 999, and you blink once, oh, thanks. And you blink once, your 5 stones would become an arrangement of 7 stones engraved with the numbers 1, 2024, 1, 0, 99, 2, what is that? 2,021,976. Let me give us a longer example. In this example, after blinking 6 times, you would have 22 stones. After blinking 25 times, you would have 55,312 stones. Consider the arrangement of stones in front of you. How many stones will you have after blinking 25 times? Okay, well, there's our input. It's pretty short. Dot strip dot split, something like that. That's probably, I've already put some input. All right, let's see. That looks right. Okay. And I'm thinking that we implement a class stone that The challenge of what is important and what's not. Yeah, interesting. Interesting. I kind of want to keep... I don't know whether this actually makes any sense, but how do I want to do this? I'm going to do something kind of weird, and then we'll see where it gets us. Something is dripping from my upstairs neighbor onto the yeah, it looks like the mic's barely picking it up. Onto the roof of my sunroof, or my sunroom. So this is where we put our business logic. And then our solution becomes map and then to get the solution we want to 25 times do input dot map bang, or sorry, I guess this is flat map bang. Each one of these, or I guess we don't even need that. We just go next, and then we are looking for input dot length. Okay. And this is supposed to be new number. There's a reason I did that, but we'll come back to that when we see part 2 and if I'm good at guessing. So I guess we implement all of our rules now. We need to implement I'm just gonna change this for n. I don't want to have to write. I could have done that a lot better than how I did it, but anyway, if n equals 0, then we return stone 1. Else if, wow, something was really janky there. I'll do that one else, that last, but we know that it's n2s length %2 0, so that's even. Or I might even be able to just say dot dot even. I don't know if that's active. Oh, I see what I did. And then else it's stone n times 2024. And so then we just need to figure out this logic. Is there a good way to, does Ruby have a nice way to split string in two? Split a string into an array of substrings based on a pattern specified. Oh, I just want the middle in half. Half is what I'm looking for. Why is this mapping through join? Oh, it's rejoining the... Okay, that's fine. So be s dot each slice s dot length divided by 2, and then we are mapping it through join because those are going to be arrays of characters, not strings. Does anyone have a better solution than that? I don't know if I'd call that better. More things that I'm not sure I would call better. Okay. Now, I guess the real question is, oh, well, yeah, I guess I can't use things before I define them. Flat map bang. Oh, well, I guess flat map doesn't come into bang flavor, so I have to do map flatten. I could also reassign it, but and we didn't. Right. Didn't do that. And find method each slice for an instance of string. What did I miss? That solution. Oh, it's chars. All right. All right, now we're here. We have not what we wanted. So S. Oh, shoot. Oh, I see. The my single letter variables are colliding with the shortcuts in the debugger. So we're just gonna switch to IRB. A. So we have A and B. No. Come on. B and S. So that's right. The thing I wanted to check is if we do 2i that. What if we do 2i that? And then the next question is what if we do 2i that? Okay, these are right. I just wanted to make sure it wasn't going to like interpret these as, I don't know, octal or something. But it seems that we are safe on that. Which means I think we just return the two stones here. In fact, we don't even need to store them in variables. Ta-da! And that's right. All right, awesome. Day 11, part 1. Historians sure are taking a long time. To be fair, the infinite corridors are very large. How many stones would you have after blinking a total of 75 times? So I assume that my list is going to go very large, and we're going to see we are going to see issues with the map is getting too big or taking too long. Indeed, it is taking a long time. So thinking about this, probably run out of memory soon. Yeah, I'm just going to I'm just looking at htop off screen. Yeah, we're currently using 100% CPU and 680 megs of memory. We're not growing that fast though. Yeah, 716, like it's growing. So let's, first of all, I want to see how fast it's going now, because that's going to be useful regardless of the right. Okay, so this is what we expect. Now I gotta think about this one. One sort of gut I have is like, oh, we can avoid instantiating new objects if they already exist. In fact, we can even avoid like if we've already computed that number, we can even avoid computing what the next one is for that one quite easily. So let's do that. In fact, we can even okay. So now we've created a hash whose default, who if we look up a value that's not already in it, will return a new instance of stone, and for that number. And so that should, let's see, what does that do? Interesting. That makes me think I did something wrong. Yeah, there we go. Okay, so that's still slow, relatively speaking. But we can also skip this. So we can say if return next, if next, otherwise next equals whatever the result of that is. And it certainly doesn't seem any faster. Interesting. Yeah, so I'm just going to put input.length here. And I'm going to switch to reassigning input rather than mutating it. That shouldn't make a big difference, but Oh, I'm using print. That was a mistake. Not puts. Yeah, so that gets pretty dang big. What do you cache? Right now I'm caching both the I'm avoiding creating new instances for each number if it's referenced multiple times, and I am having so you always get the same instance of a given number, and then I am caching the result of checking what the next stones are for a given stone. Just to put this even more in perspective, let's say this gets n, right? Yeah, so starts to grind to a halt around 40. We get up over cache. There's a stone at any given depth. What does that mean? Well, how do I use that? So how does that help me, Fig? I'm not following. I know there's something like this feels dynamic programming-y, but I'm just not quite seeing it. I found the X iteration. You see a stone value Y. Cache that. But what do I do with that? Oh, wait, so if I'm, yeah. If I look at, say, the first element, I can go all the way to the result of that element. Right, yeah, the stones never interact with each other, which is like one of the prerequisites for this being a dynamic programming problem, which I'm now convinced it is. Broken down into subproblems, the results are saved, and then subproblems are optimized to find the overall solution. Yeah. Right. So, what's my cache look like here? All right. Still wrapping my head around this one, but they are identical, so we can use the knowledge gained from early stones on later ones. Yeah, exactly. I'm just trying to think of how I structure the data to make that work. I wonder if I can just change the API to this. And move the logic up into there. I don't think this is useful. I mean, maybe it is. Maybe it still is. If depth is 0, just return the stone itself. Otherwise, we compute down to that depth. Caching our results as we go, or using existing results. At this point, I don't even know if we need this class. Probably easier to just operate on numbers. But is actually 70. Interesting. So we can get rid of this. We can say, oh, I want this. Just flatten just already flatten Ruby. Does it just do one level, or do we have to tell it to go to do all levels? Or do we just want to deal with that at a different level? It flattens deep. Cool. Yeah, it takes an argument to. Okay. Okay. I just got to figure out what to write in here. Otherwise, it's something. I don't know. Oh man, come on, brain. Yeah, I feel like I'm just like not quite seeing what I need to do now, though. If it's then we okay. Depth, yeah. Depth dot times am I gonna do a loop in here? Okay, so let's make this an early return. And then otherwise, we'll do something else. Why is this not syntactically correct? Because I've left the word def there. Or I can even, and then save ourselves. I don't even need that as early return now, because now I can say the result is equal to I'll need the depth. Compute n to not n. We call it depth and something like that. Return result. Then compute No, I'm not on the right track. I mean, this allows me to cache in here. Oh, but it's not N, it's... Doing dynamic programming stuff always breaks my brain. No, this is okay. Yeah, no, this isn't. This obviously isn't right. It's like result dot map. Okay. Just having those flashes of, you feel like you almost have the answer. Um, that doesn't make sense. So it's always going to be just the one thing. Um, it's just interaction though. Ha 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 ha. Hello, answer. Um, and this is where I could leave I can leave this in there. That way I don't have to expose it. Yes. Okay. So this now computes. This should compute it recursively. Let's just do it with 25 to see if we can still get the result. I'm sure I've done something wrong, but instance of stone. Put it in an array. Array of arrays. Okay, so we're not flattening them. Flatten them there. Well, that's wrong, but kind of funny. Hey, I'm wrong. It looks like you've got an immutable class stone that should return either 1 or 2 stones with the depth off by 1. Oh, and I don't think we need this. This optimization did not help us. We're still just getting 8, which is very funny. Is that the number in the input? Yes. So that's not getting us anywhere. Why? Okay, well, I'm not thinking too hard about that. Just trying to get some data here. I mean, that looks like we're recursing, yeah. Oh, interesting. Kind of want to remove this. I don't think this is strictly necessary. So we're kind of conflating our two APIs here. Oh, stones. Where did I write stones? Okay, still doing the wrong thing. Great. That's of no use at all. I meant to do that anyway. But I don't know what that's going to tell me. That's going to tell me it's not actually advancing anyway. So let's think about where are we going wrong here. Well, first of all, we've got a totally pointless method. Why are we not getting next values? Like, next surely is being called. Yeah. And is returning things. All right, debugger time. All right, so we are in here. Depth is probably equal to 25. So let's just try some things. 0, 0 turns us the block itself. 0, 1 should return us a 1. Should return us 2024. So these are all working. What the hell? It's the same value. Oops, I just meant to do that. Intriguing. Well, how are they not equal? Just looking for a, what I assume will be then why wouldn't these be equal? The last few characters are all equal. All good, all good. Was that our result for part 1 before? 21,306. Oh, okay, so it was. Okay, so I was just missing a flatten. That's fine. So now we change this to 75. We should expect it to go too slow, which is fine because we're not actually caching any values yet. Okay, so we're back to a solution to part 1 that works, and now it's just a matter of actually, like a recursive solution, of actually doing a little dynamic programming. equals something like that. And then and then this is an depth. If that, then we return that, else. I hope I'm doing this right. Wait, you can't key not found. I've given you a block. Oh, V. What's V in this context? You can't. There's no such thing as key not found in this context. Okay, I'm gonna back up and back outside. Results can just be a new hash. Results and depth or equals if is 0 stone.new and what this one is, I have no way to know how bad this is. Other than by opening htop off screen. Ooh, this one is ripping. This one is getting increasing in memory usage much faster than previous versions. We are at 1.125 gigabytes already, which doesn't seem, I mean, I guess one way to test whether this actually works is to run the, yeah, so this is probably not working, but run it for the 25 version again, see what happens. Okay, so this does still work. So why is it, what am I missing here? Yeah. I could bring back the other optimization if that helps. So one thing we can do is rename this to compute. Then we can put our original optimization in here. The currently running one is over 2 gigabytes now. Great. Oh. Fetch key not found. Line 10. Oh, am I supposed to be... Does that not work if I call fetch? No, I got the same... Well, I should double check that's the same. Wrong number of arguments. Line 37. Oh. Well, how could that be wrong number of arguments? Oh, I see. I see what I did. It's fine. Wow, this one is growing even faster. We're currently using 4.5 gigabytes of memory, almost 5. Now we're at 5. Something tells me that if we're using 10 gigabytes at the moment, that this is not actually the right solution. I don't think this is going to be a real performance improvement. Well, I feel like we must not be caching the right thing or something if this is still... Our memory usage is dropping now. I want to see this play out. I want to know what's going on now. Did this just get to a solution? Memory usage is dropping like rapidly. We were over 10 gigs. We're now at like 5. Oh, and now we're going back up again. The CPU is also not pinned. We're not swapping either. I have 36 gigs, and according to this in the machine. My laptop's hot though. We're floating in the 5 gigabyte range. The CPU not quite pinned. This hasn't dropped below 5. Keeps getting close and then going back up. I don't know why it would be going up. Why it would be going down and up. Because I just want to get a little bit of visibility into this. Uh-oh. I don't want to die. CPU just dropped below 80 though. The heck? All right. So this is probably the first one. So it's trying to compute down, and it's so this is the recursion happening. Oh, we're not. Ha 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 ha. We are using next here. When we should be is that right? I feel like we want to compute each. If we have a bunch of stones, oh, come on, brain. We're not. I feel like we're not calling compute enough here. Is only is yeah. Like, okay, let's just comment this out. Because if we have all the ones from the previous depth, flatten them. I feel like this should always be flattened, but maybe we just stick a flatten on here, so we stop having to deal with these extra flattens. And we want to iterate over those, computing the values for yeah. This isn't quite right though. I'm close to something though, aren't I? Because there's this one never hits. Create external hash in the input. I don't know what you mean by that. All of our context is at the class level here. Location is not cached. This, like all of the calls to compute have access to this results hash. It's persisted across calls to it because we're memoizing it. And this obviously isn't. This would be like that or something. Oh no, this could be depth 1. Then we have a second base case. If depth, else if depth is 1, then we know. Then we want to compute. If depth equals 0, should return 1. do you mean should return 1? It does return a single stone. I've got a syntax error somewhere. I don't see it. No, that's not a syntax error. Why is my syntax highlighting not working? Star for an instance of stone. Okay, that's cool. That's cool. You are not exiting the recurse. What do you mean I'm not? I've got two base cases, depth equals 1 and depth equals 0 and depth equals 1. Okay, I've got two base cases. Somewhere I am calling compute with a stone here. That's doing something. Besides, I mean, it's using a lot of memory. And it's getting really slow. I mean, so we invoke, we ask it to compute each element. This should still be flat map. Down to the depth of 75. Actually, just as a sanity check, let's just make sure it still computes 25 correctly. It does. Okay, so we haven't broken the logic. So we ask it to compute to a level down to 75. Inside of compute, we create our results hash. And then we either look up the result of computing n down to that depth. If it doesn't exist, we check if the depth is 0 and return. In fact, we don't even need the 0 case, do we? We're never calling this with 0. If the depth is 1, I mean, this is kind of a silly way to write this, but we return an array containing, I guess we're already calling flatten, so we can just do that. So we return an array containing whatever the next values are for that stone. Otherwise, we try to compute the values for one less than that and get their next values by computing to a depth of one further for them. This logic up here is just to cache the actual instances. So that we don't create multiple instances for the same numbers. I'm just printing some things just to get some. It's a lot of ones, but that makes sense to me. Well, I printed a lot. Okay, so that's what I expect to see. Counting back down to 1. Is it completing any of these? Is that valid? No. Nope. In compute, yes. I removed if 0 because we were never hitting that. Because we have a case that says if, so like we're always calling it, so we start by calling it with 75, which then calls it with minus 1 less than that, which calls it with 1 less than that until it gets down to 1, and then we return the result of performing the operation once. So there's no 0 case. We were hitting the 0 case before, but that's because we weren't caching values enough. Because stone values and depth are separated. Yeah. I mean, we can compare this solution with yours if you want to post a link to it. I'm happy to see what we can learn from yours that will lead us to what's not working with mine. Next doesn't know anything about depth. I like that it's running in the background, having not even completed the first one, and using like 20% of my machine's memory. Yeah, go for it. Oops. All right, close that. Let's make this a little bigger. So you read your rocks in, map them to integers, then you create a cache. Turn 1 if level dot 0. Don't fully understand that, but I'll keep reading and we'll see what we get. So cache is a hash of hashes where the outer keys are the levels and the inner keys are the values. So that's similar to what I'm doing, except that I have the I'm using a key that's got both values in it. Tick1 value dot 0 0. I still don't understand this. Else if string equals, okay, so that's basically what I was doing, and then you do slightly different logic, but that's your string split, and then this is your option for the base value. So I suspect it's in this part that I don't understand. Why are you returning 1 if level is 0? What is the escape? No, I understand that. What is the return value of tick? It's the number of values. The thing I have running in the background is now using 50% of my memory. Yeah, it matters, but like you're not even storing the values. I think that's a huge difference between our solutions. Is that mine is storing the actual values. Turn 2 rocks. Yeah, but like this tick method is returning the number, not the, and you're recursing on that. Whereas my compute method is returning the array, which is going to make mine use vastly more memory and vastly slower. Like the trick isn't that mine's wrong in the logic or anything here, or not caching the right values. It's that my approach is not feasible computationally. You've managed to get around storing the values, like storing the actual intermediate arrays with an array of arrays. But like tick returns a number. So this cache is a hash of hashes that contain numbers. I don't see you storing arrays anywhere. Unless I'm missing something. But I think we can do that. The question is just how we do it. The result of computing. The cache, your cache contains, it doesn't contain the array though. It contains the total number of rocks. Am I right? I don't, like, you're not, tick returns a number. And we're putting results of tick into the cache. So your cache is just numbers. Yeah. That's why, like, that's the big difference between ours. That's why mine is so slow and yours is so fast. Is because I'm actually storing the entire results rather than just the total numbers. I still don't follow what you're saying about flatten. Like, there's no calls to flatten in your code. Your code completely circumvents needing to flatten anything. But I like it. So this would become sum, and set this back to 25 for now. Well, I'll try and yeah. But thank you for providing that. That sort of enlightened me as to why mine was not working. Your approach is very clever because it totally circumvents, because it's recursive, it circumvents needing to store those arrays at all, which turns out solves the memory issues. Yeah, exactly. All right, so now we have a different question. So now we say if depth is 0, it is a 1. We like that. Otherwise, we do one of a bunch of things. So yours was interesting. So now it's like else if. So we kind of combine the logic here. In fact, this kind of gets rid of the point of having stone as a class. Because it's really just hurting us in terms of our design. So now if n is 0, then we compute 1 depth minus 1. I think that's what, yeah. Else if is that right? Oh man, I'm still struggling to wrap my head around that. Otherwise, we want to do our this logic. Otherwise, it's compute n times 2024 depth minus 1. And now we don't even have stones as a thing that's referenced, so we can just get rid of all this. And this is now just a module. And we still have reference to stone somewhere, and that's this one. Okay, because this is wrong, because now we want to sum these map join map to I, and then sum them through compute. Hey, and that's a correct result. Hey, that's probably also the correct result. All right. It is. All right. So today's winner is Fig for helping me hunt down through your solution what was going wrong, or why my approach was totally busted. The summary was that I correctly identified that this was a dynamic programming problem, but was trying to store sort of the intermediate results rather than the actual just results, the number of stones that I was looking for, which was prohibitively like it technically worked for small numbers, but it just, the memory usage exploded for larger numbers. That makes sense. A little tricky. Definitely dynamic programming problems are always a little tricky, but thanks to Fig, we got there. So I'm gonna leave it for there today. I gave up coffee starting yesterday, and not still feeling the effects of that. So I'm gonna go take it easy. But thanks for coming out, and see you again tomorrow morning.